So this is a problem I encountered on one of last year's midterm reviews, and I think this is a great problem to practice using the graphing calculator on. We're given a function and we need to find the intercepts and the coordinates of the max or minimum. And the key features I want to use are the zoom features on the calculator. Zoom box, zooming in, out, zoom standard, and zoom fit. So I've actually entered the equation here, and if we go to our graph, I did zoom 6. Normally I would just hit graph, and the graphs are usually in the standard window, but regardless, as you can see, there's nothing on the graph right now. So most tutors at this point would say, oh, okay, let's go adjust our window and maybe start with 1,000 in both X and Y directions. All right, let's try that. And we kind of can see a little bit of the graph. We could get some of the intercepts right now, but this isn't an entirely great looking plot right now, or at least in my opinion. So the tutor might next say, oh, okay, let's try a different window. Let's try making it bigger. All right, so they might do 5,000 in maybe both directions. I don't know. So it didn't really have an effect on the X direction, but in the Y direction, I mean, it's still kind of, we really can't get the max. And at this point, I'm starting to get a little frustrated, just because I really don't like tampering with the window. You do have to kind of really just guess and check and estimate what kind of values and ranges you're using, and I think that requires a lot of thinking. And frankly, time starts to add up when you keep trying to change the windows. So my approach is a little bit different. I like to graph using these zoom features. If we're given kind of a weird function, or maybe in this case a quadratic with kind of big numbers. So let's go back to the standard window. Now, of course, again, we're not going to get anything. So what I would do first is I'm going to zoom fit. Zoom fit allows the graph to be visible on the screen. So this kind of, obviously, you can kind of tell this is not really the graph. If anything, it looks like a linear function right now. And it's not, I mean, it's not our full graph, but this is a start. So now after we fit the graph, next we can zoom out, which is zoom 3. And again, we kind of get the same thing, but I'm just going to zoom out again. And as you can kind of start to see, we see a little bit of curvature, which means we're going in the right direction. And now we're starting to see the parabola. I'm just going to keep zooming out. So this is cool. Now we can actually see the entire parabola on this screen. But the problem now is it's kind of tricky to at least kind of see spacing or see where the max or even where these intercepts are. So I am going to do something called zoom box, which is what we have right here. So zoom 1. So the way this works is that you have this little cursor here, and basically with the zoom box feature, you can kind of create a box around any section of the graph, and then it'll zoom in on that particular box that you make. So I'm going to start maybe somewhere right here. What I'm trying to do is I'm trying to get a clear idea of where the where the intercepts and the max are. So now that I have my box here, I'm going to click enter. And cool, not bad. So we can kind of see a clear picture of where the intercepts are, and also the max and min. Or I should say in this case, the max. And of course we could just use our zoom or calculate features to find the maximum. So I'll go just to the left and just to the right, and we have our maximum at x equals 500. So I can write that down. Oops. 500, 9500, and then we can find our zeros, or I should say our intercept. And I'm actually going to find the x-intercept specifically. So there's one at 64, one around 64.10, and then let's go on this side. And this video is more about the zoom features, but I think it's also worth talking right now. Just some students don't know about these calc features, and I really think that these calc features are make life so much easier, especially on the tests when they may be crunched, and it's sometimes faster doing graphing and finding rather than doing it by hand. So 935, 0, around 935. And actually, for the y-intercept, so to show a different feature, instead of using the 0 feature again, I could just find the y value when y-intercept naturally means the x coordinate is 0, right? So I'll just do the value where x equals 0, and our y-intercept is 0, negative 3,000. So I just want to wrap up by saying, or summarize by saying, these zoom features are so powerful. In my time tutoring at SALT, I never ever touched the window. And if I touch the window or mess with the window, I would only do it if the problem specifically asks to use a certain window or to identify a window. And actually, now that I have my window open, as you can see, I personally can never ever come up with such a specific kind of range of x and y values to, I mean you're going from negative 15,000 to 20,000, and then you're going from the 200 range to the thousands. I mean, these are different magnitudes, and it's not really easy to guess. And I think this is a pretty clean representation of the graph. The sequence is usually starting with the standard window and fitting it, and then proceeding with zooming out or in. And the box feature, it's not absolutely necessary, but I like the box feature just because it's so nice to get a snapshot like this, and it really does make it more clear. But yeah, I really think these zoom features are very undervalued, and I think they're more efficient than using or trying to generate your own window.